Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of zeros of quadratic functions. This is standard A.7B in the great state of Texas, and we are using item number 37 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a statement here, and the statement is actually given to us, this function is actually given to us in standard form. So that's going to be helpful because we're going to need to find the a, the b, and the c. So remember, in our standard form, right, it's f of x equals ax squared plus bx plus c. So in this particular function, what do we know? Well, the a is going to be just that coefficient 2. The b is going to be a negative 3. C is going to equal a negative 5. If we can get our function to look like factored form, so factored form looks like this. F of x equals a, x minus u, x minus v, and sometimes we have an a and sometimes we don't. Then the u and the v are actually going to be your zeros or your solutions, which is what we're looking for. Because then you can set each of those to equal to 0 and then solve for the x. So how do we get from there to there? Well, we can use this diamond method here. So what we do with our diamond method is, once again, when we have it in standard form, we're going to take our a and our c and multiply them. So our a is 2. Our c is negative 5, so 2 times negative 5 gets me a negative 10. We take our b and simply write it in the bottom. That's negative 3. So what we're looking at or thinking about are what are two factors that will multiply to negative 10. Well, it's either going to be 1 times 10 or 2 times 5, with one of those factors being negative, and then add to negative 3. So when we think about it, we should think, okay, if I do negative 5 times 2, that's going to multiply to negative 10. Negative 5 plus 2, that's going to get me to negative 3. So that's what I'm looking for. So what I'm going to do now is I'm going to rewrite the original function, but I'm going to replace that 3x with a negative 5x plus 2x. We'll see why in just a moment. So 2x squared. Instead of a negative 3x, it's negative 5x. And it's going to be a plus 2x, because we know that's the same thing. Negative 5x plus 2x gets me a negative 3x, so I didn't change it. Just going to split it up a little bit. Because now, what I'm looking for is I'm looking to kind of factor out some things from these terms here. So what is a common factor that I can pull out of this first term here? Well, only thing that's common between a negative 2x squared and a 5x is going to be that x. So I'm going to pull out an x. It's going to leave me 2x minus 5. Well, look at that. Look what I have right here. I've already got a 2x minus 5. So that gets me common factors, and that's really what I'm looking for. So what I want to do is I want to now factor out of that 2x minus 5, and see what's left. So if I pull the 2x minus 5 out of that, from each term, what am I going to leave? Well, that first term, it's just an x. Right? X, and then what's over here? Plus. There's nothing there, so that's going to be a plus 1. And there we go. Bada boom, bada bing, we have our factored form. So what we do now is we set each of these to 0 to see what the zeros are going to be. So 0 equals 2x minus 5. Solve for x. It's going to be negative 5 equals 2x. So x equals negative 5 halves. Then we do the same thing here. X plus 1, right, equals 0. And so that's just going to be negative 1. So those are going to be my two factors here. And so we see we've got that right here at negative 1. And we've got, that's not a negative 5 halves, that's a positive 5 halves. That's a positive 5 halves. And because we see we've got the correct factors right here, and my answer is going to be C.